Okay, so exercise 2 here asks us to write a program that prints out the lyrics to the song 99 Bottles of Beer on the Wall. We can do that. Let's think about how we would need to do that. Well, how does the song 99 Bottles of Beer on the Wall go? It goes 99 bottles of beer on the wall, and then etc, etc, etc. And the next line goes 8 bottles of beer on the wall. And the next line goes 97 bottles of beer on the wall. So I hope that should be obvious immediately what we need to do here. And that is, we need to do a for loop, right? We don't want to print each of these lines separately. We don't want to write them separately by hand, because the only thing that changes between these lines is the number of bottles of beer on the wall, right? So that's the only thing that we need to change. The rest stays the same. So when you have a situation like that where you need to do a bunch of something and it's all mostly the same with a small difference, iteration is absolutely where you want to go with that. So we need to do a range, right? We're going to need to print something 100 times, 99 to 0, right? So we're looking for a range of 100 times, so we want to create a for loop that would be for, we'll say I in range 100. And this is wrong. Why is this wrong? Immediately think to yourself, why is this wrong? If you said to yourself, because doing this is going to print every number from 0 to 100, you're correct, right? It's that's not what we want. We want to go in reverse order, right? We want to start at 99 and then go all the way down to 0. So we can't do this for loop that we've constructed here using this range. We need something else, something a little different. We need to do a for loop that goes from a high number down to a low number, and the range function allows us to do that. Let me really quickly stub out our code with comments. We want to print the lyric 99 times, reducing the number of bottles by 1 time. There we go. So we need to set up our for loop then, right? We need to go for, and then instead of I this time, I'm going to use bottles to represent the number of bottles that are left. That just is a better name for this, what this variable actually is going to be used for. So you might know, if you watched the last video, that I said I can be used generally as a good way to iterate through a range of numbers. But it's not necessary that we use I. There's nothing special about I, it's just convention. So instead I'm going to use bottles here, just because bottles is more descriptive, and it's going to help me remember what that number actually represents inside of my for loop. So for bottle and range, and for the range, I need to do my start, my stop, and my step, right? Those are the 3 things that I need to give my range function. And we know that we can just do, we can just ignore everything and just do the stop. But you can't do that here, because you can't put a stop and reduce the number and step backwards through a range by doing that. So we know where we want to step backward, which means that we need to step by -1 each time. So every time we go through the for loop, we're going to decrease the number of bottles here in this range by 1. We know we want to stop when we hit 0, which means that we want to start at 99. So it's not going to actually print it 100 times, it's going to print it 99, because I'm not going to print a line for 0 bottles of beers on the wall, because you can't take a bottle of it. It'll make sense in a second. So we're going to go inside our for loop. We're going to set up the lyric. We're going to say print, and we need to construct our lyric here. The lyric we need is, it would be 99 bottles of beer on the wall, 99 bottles of beer, take 1 down, pass it around, 90 bottles of beer on the wall. There we go. That's what our lyric should print the first line. Now we need to generalize that so that it's something that we can read. So instead of 99 here, say bottles, and we're going to use concatenation, string concatenation here in order to make this work. So we're going to use string bottles plus bottles of beer on the wall, and then here I need another place where I need to replace the 99, so I'm going to use plus string bottles. There's a better way to do that, and I think I'm going to do that because I don't want to cast this as to a string every single time. So I'm actually going to create a variable here. I'm going to call it bottles string bottles, and that's, I think, good for this because I'm going to replace bottles in. I'm going to place bottles in this print statement here multiple times, and so I'm going to cast it as a string just once rather than casting it as a string multiple times inside of this actual print statement, and that just saves it. It makes it so we only call this once, this function once, rather than calling it 3 times. Just something to think about. How many times or how efficient your code is being. So instead of string bottles, and down here I'm going to bottles string plus bottles of beer on the wall plus bottles string plus space bottles of beer. Take one down, pass it around. And here's an interesting thing. If I run this now, I'm going to save it, I'm going to run it, and we'll see that it looks like it's basically working, right? 99 bottles of beer on the wall, 99 bottles of beer, take one down, pass it around. 98 bottles of beer on the wall. Then we get 98 bottles of beer on the wall, etc. And then take one down, pass it around, 98 bottles of beer on the wall. Right? Whoops. Because of the way that I stubbed out my print statement there, I'm actually getting 98 bottles of beer on the wall as the number remaining every single time. And so we don't want to do that. That's bad. That's obviously a bug in our program, right? It's I remember last chapter what kind of bug that is. That's kind of a semantic error, right? It's not something that's throwing an error because of the syntax. It's not something that's throwing an error at runtime. It's something that is making our code function in a way that we didn't intend it to function because we didn't structure our code the way that we thought we did. So it looks like our countdown, however, for start of the sentence is working just fine. So we don't need to fix that. All that we need to fix is where we used 98 here. So let's replace 98 with something else. So how can we get 98 from 99? 98 is just 99 minus 1, right? So to get to 98 from 99, or 99 minus 1 from 99, we need to bottles minus 1 to get to 98. Does that make sense? What I mean is, let me actually write this out. What I mean is that my test statement here was 99 and 98. So to get from 99 to 98, what 99 from 98 actually is 99 and 99 minus 1. So when I replace 99 with bottles, what I'm doing is actually bottles minus 1. So we're going from specific to relative to general, kind of how we're doing this. So this is a common way to break down a mathematical problem in code. If you need to write something that you want to solve algorithmically or programmatically where it can be solved for any value of a number, what you need to do is start with a specific example and see how do all the numbers inside of here relate with each other, and then go to a relative example and figure out how do all the numbers in this problem relate to each other relative to each other. If I was trying to break it down so I only had one variable to change, what would that be? And then replace that number that you've made everything relative to with a variable, and then make everything relative to that variable. Is how you kind of go from specific test statement to general solution. I'll cover more that. I'll harp on that all the time over the course of this stuff. kind of a method that you need to become accustomed with in order to solve these problems. So we're going to say plus the string version of bottles minus. So it says take bottles minus 1 and then return the string version of that. And so if we save this and run it, we should get 99, 98, 98, 97, 97, 96, all the way down to the very end, 1 bottle of beer on the wall. So that's a little semantic error that we'd be able to fix if we wrote an if statement. We could fix that. We're not going to bother writing an if statement to fix it, though. 1 bottles of beer on the wall, 1 bottles of beer, take 1 down, pass around, 0 bottles of beer. So there you go. There's a way that we could fix that without if statements. So let me real quick just troubleshoot that, right? So what if instead of going from 99 to 0, I went from 99 to 1, which means print every number between 99 and 2, because this second number is non-inclusive, it's exclusive. So do that, and then print at the very end, just hard code that last string, which is 1 bottle of beer on the wall. So I'm going to just hard code this last string, that way we get it so where we don't have that weird issue. So if we scroll down here, we get 1 bottle of beer on the wall, 1 bottle of beer, take 1 down, pass it around, no more bottles of beer on the wall. So it's an easy way. We just iterated through all the stuff that could be iterated through easily, and then we printed the last line separately for grammar purposes. And again, like I said, we could have solved that with an if statement, though it's maybe not useful to solve that with an if statement, because if we put an if statement inside of this for loop, it would have to check that if statement every time, essentially doubling the cost of that for loop, right? So it's probably better in this case to just print it outside. That's either here or there. That's kind of an extra little thing. If your version didn't include taking care of that grammatical issue at the end there, it's perfectly fine. All right, see you next video.